Atomic Rules is showing both its Arkville data mover and TK242, a complete packet capture solution. Both of these running on the Bitware IA440i or IA420F card. Arkville and TK242, while both products 100% from Atomic Rules, could not be more different. Arkville, like other Atomic Rules IP cores, such as our UDP offload engine, are IP cores. They require expert FPGA competencies and programming skills. On the other hand, TK242 is designed as a complete turnkey. The TK in TK242 stands for turnkey solution. No FPGA programming is required. No C or Python program is required. Out of the gate, it is a complete packet capture solution. Let's talk a little bit about Atomic Rules Arkville. So Arkville is all about Gen 5 by 16, full stack PCI DMA, 60 gigabytes per second, up, down, at the same time. It's as much performance as you'll ever get out of PCI Gen 5 by 16. We're through 25 vetted releases, and we're using standard APIs such as AXI and DPDK. Arkville, as the premier DPDK DMA engine at Gen 5 by 16, is capable of moving over 400 gigabits per second up and down at the same time over PCI Gen 5. Notice the flat, symmetric up-down performance across the board. Multiple Arkville devices can be used at the same time. As we see here, the device's PCI address, their build ID, the build hash, the driver type, all of this is capable directly from userland, and we're showing all of this on the Bitware 440i, which features the Intel Agilex I series Agilex 7 device and its R-Tile. For the R-Tile in particular, we have the capability to look at the 500 megahertz R-Tile interface and look at every single packet going up and down at 500 megahertz. Key to the quality of our IP is Atomic Rules Jenkins CI/CD testing of this IP. With TK242, the user is in control of right-sizing the storage capacity and throughput to their needs. We designed the system to fail softly. What we mean by that is that if the storage system is insufficient to keep up with the amount of data the FPGA is producing, packets will be dropped, and they will be very carefully notated when they dropped. All of the JSON metadata and such is captured. So this means that to a user evaluating TK242, they can start with a under-provisioned storage system and discern themselves where the skyline is, where the point is that they need to capture. We designed the system to work with high-performance disks that go up to and even above 200 gigabits, but very few users actually need 200 gigabits all day long and the expense of disks that provide that bandwidth. So the process involves setting the system up, capturing some packets, and asking themselves the question, do I have enough throughput? We do provide with TK242 some diagnostic tuning capabilities that allow the user to incrementally and parametrically increase the throughput. We use the parameter in terms of bytes per cycle. It's really just a scalar that can be used to adjust the data throughput without having to actually have their own data generators. TK242 has these data generators built in for BIST. So if you don't have your actual data source available, and you know, for example, I need to maintain 197 gigabits per second all the time, you can tune the data generator to 198 gigabits per second, a little more than you'll ever need, and verify that your packet solution, your storage solution is capable of storing the throughput and capacity that you require. So getting started, all that's necessary is a supported card from Bitware. We support numerous cards, and many of them are available off the shelf, same-day shipping from Mouser. With that board in hand, it's a matter of installing the installation, which takes minutes, and there you are with your Linux system and your storage capturing packets to disk. It's hard for me to understate how different this is in terms of getting started to something of a more elaborate packet capture infrastructure. What's interesting is, despite these large differences between the turnkey nature of TK242 and the IP core nature of our IP cores, both are using IP 100% from atomic rules. Someone might look at TK242 and see the utility, but say, oh, atomic rules, could we add our own special filter inside that? And the answer would be, of course, let's talk to you about that. On the other hand, someone might look at TK242 and go, wow, we get it. I see that you have all these cores interoperating together. We don't really need a packet capture solution, but boy, we could use Gen 5 by 16 PCI DMA all day long. Your Arkville brand of DMA looks terrific for that. Talk to me more about that.